A shell script is a plain text file that contains shell commands. So this is a shell or terminal where you can type your commands in Linux. And a shell script will run those commands automatically from the file. Now, to have any shell script, it must meet certain conditions. So you want it to end your file name in .sh. So that makes it clear that it is a shell script. If you take a look inside the file, you must define the command processor. So in this case, it's bin bash. So add this line to the top of your file. You can also use another command processor if you want. The only thing that's required is that this command processor is installed. And so if I type where is bash, you'll see bash is installed and the path is actually the same. Now if you're using something else like Z shell, you can use the path to Z shell. Now in almost all Linux systems you'll have bash installed, so you can set the path to this path. Then you want to have your shell script executable. So if you recall, the script is named myscript.sh, and to make it executable, type chmod +x myscript.sh. So that will make your shell script executable, so that you can run the shell script. Now to run the shell script, type the command / and then your script name, so that's myscript.sh. So you'll see now the script has been executed. So if you cannot run the script, be sure to check that your script is executable. So run this command to make it executable. Let's create a simple shell script. So you can do that with any text editor. It can be a command line editor like Emacs, VI, Nano, or it can be a graphical editor like Notepad or Mousepad. And so if we create a new file, so let's say call it myscript.sh, and type the line, this line, so that it will load the shell, and then type any command, so like echo hello world, which will output the message hello world. So save it. You can press Ctrl O to save it in Nano, but really doesn't matter which text editor you use. So this is the script, just a 2-line script, and save it as myscript.sh. Then we want to make it executable, and you can do that with this command. So chmod +x to make it executable, and your file name. Then you can execute the script. So if you run it, you'll see the message hello world appear, and so the script has been executed. So the echo command outputs anything you want. So you can put your message here, and if you run it with the / command, your script, you'll see your message appear in the terminal. Let's get keyboard input. So we'll make a program, a shell script, that asks for your name and shows it on the screen. So open or create a new file. So I'll call it name.sh in any text editor you like. Then define the command processor. So I'll use the bash command prompt. And you want to say some message, enter your name. Then you want to read the name or to get the name, so type read name. And then you can output that, so say your name is, and then type $name. So important in shell scripting, you'll have the $sign for the variable you just read. So the variable name is read from the keyboard, and to continue using it, add the $sign in front of it. Save the file, so then make it executable by typing chmod +x name.sh, and you can run the program. You'll be asked to enter your name, and it will output the name that you entered, so it will get keyboard input. You'll see that it adds a new line right after it asks the question. So to prevent that, open the file again and type -e, and at the end type \c. So save it, and if you then run the program again, you see it doesn't add a new line to the question. So you can type it on the same line and continue your program. So that's minus. Let's take some user input or keyboard input. So we create a new program called colors.sh. You can use any text editor you like. Make sure to include the line to load the shell or the command prompt. And then we'll say choose color. And to make a choice, type select space color and then from or in your list of colors. And add these lines. So that will ask for user input. And then you can say the chosen color. Make it executable with this line and execute it. So now you'll see we get to choose a color. So if I type, for example, 2 and press enter, you'll see it outputs the chosen keyboard input, so the variable colors. You'll see the choice or the keyboard input is now stored in $color. So this line will, or these lines will select, make a menu for you in which you can choose between the given options. You can repeat or loop over commands. So let's create a new program. I'll call it loop.sh. And let's say we write a message, hello, and then you want some name. We can loop over a list of names. So for name in this line, and finally type done, and don't forget the command processor. So with this script it will loop over the names as we define them. So make it executable and run it. You'll now see it shows it executes the command for every item we defined in the list. So for every one we defined, it repeats the command echo. Now this can also be done for files. So if you type for add a star, then echo your file name, type done. If you loop it, now it will show every file in the current directory. So you'll see that we have a star here, which will loop over every file in the current directory. So you can show every file. Now you can also add star.sh, so then it will show you every shell script. So if you run it again, you see all the shell scripts in your current directory. Now this might differ on your computer, depending on which shell scripts you've created so far. So that's how you can loop over the files in the current directory, just a star, or you can add an extension like .sh, which will show the files in the current directory, the shell file. This will also work for numbers. So if you want to count from 1 to 10, just add this line at the end, and this will loop the variable I from 1 to 10. So if you run it, you'll see it loops from 1 to 10 or executes the command 10 times. So this will also work with, say, 1000. And if you run it, you'll see it counts all the way to 1000. You can also change the step size. So if I say 1 to 10 and step size 2, you'll see counts from 1 to 10, but takes steps of 2. So you can loop over different things, over numbers and lists and so on. You can also conditionally execute the command. That's done with an if statement. So if we create a new file called numbers.sh, you first want to load the shell and get a number. So we'll make the user type a number between 1 and 10. And if the If the guess is correct, it will tell the user. So it will run this command only if the variable guess is equal to 6. So run the program. If I type 6, it will execute the command. So you'll see correct. And if I type any other number, it doesn't execute it. Now you can also say a message for every other choice. So if it's not correct, so this is the sign for not. So if the variable guess is not 6, then it runs these commands within this part. And finally it ends. So depending on the variable that's inputted from the user, it will either run this command or the other command. So that's what an if statement does for you. The shell scripting also supports lists. So you can define a list like this. So it could be a list of colors in which you will define every item in the list. Then you can loop over the list with this line. So this will loop over every list item, so for every color. Then you'll see color is the unique variable every repetition. So you can output color, which is wherever it's currently in the loop, or wherever it's currently. So first it will be red, then blue, green, yellow. It will output that. So these lines will just loop over your array. So if you run it, you'll see it shows the list items. You can also show a specific list value. So let's say you only want to show the first value. Then you can specify 0. So zeroed index is the first item. So that's the case for shell, where you start with 0 for counting in lists. 1 would be the second item, 2 would be the third item, and so on. So 0 is the first item in the list. And you can add the dash in front to make sure that the other lines are not executed. So that turns the lines into comments, which are ignored in the script. So save it, run it, and you'll see that it outputs the first element of the list. So if I run it, that shows the first element of the list. Or if you were to change it to 1, that would be the second element in the list. 2 would be the third element, and so on. So this is how you can create a list with just this line. These lines would repeat for every item in the list, and this shows a specific item in the list. So let's take a look at strings. A string is just some text. So create a new program. I'll call it mystring.sh. Include the bash processor or whatever your shell you're using. Then you can define a string. So that's just some text. Let's say hello world. You would be able to output that. So save it, make it executable. And if you run it, you'll see hello world. Now the interesting thing with strings is that you can create substrings. So if I were to say from the first character to the 5th character, could be like this. Okay. Now the interesting thing with strings is that you can create substrings. And so if I could say create a new string based on the first string, but only from the first character, which is 0, to the 5th character. So we create a new string, string 2, based on string, from 0th character, which is the H, to the 5th character. Then if you run the program, you see it only outputs hello. So it took only a part of the string from the 0 to the 5th character. Or if you want, you can take from the 5th to, say, the 7th character. Or just different positions in the string. So that's the interesting thing about strings, or one of the interesting things, is that you can create substrings. You can create functions in bash scripts. So if you create a new bash script, we'll define to use bash, and then we can make a function. So we type function, the keyword function, and then your function name. I'll call it hello. And use these brackets, so this is the beginning of the function and this is the end of the function. Then you can do something in the function, like say hello world. But now if you would run it, nothing would happen. There's a function, but it's not called. So type the name of the function. In this case, it's hello. So hello is the name of the function, and this will call the function. So now if you make it executable and run it, you'll see it calls the function and outputs hello world. So you can call it multiple times. So if you repeat hello several times, the function hello will be called more than once. So it will do this logic repeatedly, so it will output that repeatedly. If you run it, you'll see now it outputs the hello world text several times. Now a function can also take parameters. So here we have a simple function which outputs hello world. You'll see echo hello world. What if we want to pass a name? Then we have to call the function differently. So let's say we put a name here, and inside the function you can then use $1 for the first parameter. So now if you run this program, you see it uses the parameter in the function call. So $1 is the first variable, so that's this variable. If you want to pass another variable, you can just add one behind it. So let's say message, and that will then show the second variable message. If you were to run it, you'll see the message or the second parameter is also used. So you can add, when you call a function, you can pass different parameters. So you can say something else, and so that will pass different parameters inside the function. So you'll see the function is called with different variables, and it also outputs different things because inside the function those parameters are used. So that's how you can pass parameters into a function. Bash supports different type of variables. So a variable can be a local variable or a global variable. A global variable can be used anywhere in the program, but a local variable can only be used inside a part of the program. So here we have a local variable, the variable var, which only exists inside the function hello. So if you try to output it outside of the function, you'll see it doesn't actually output the variable. But if we were to output it inside, it will output the variable contents. So if you now run it, you'll see it outputs hello here, which is the variable contents. So you'll see that the variable var exists inside the function hello. It's called a local variable. Now if you have a global variable, it can be used anywhere. So let's say we create a variable x, it's global, or with the text global in it, it's a global variable. And we can output x in here, or we can output x in here, or anywhere. So that's the difference between a global and a local variable. So if you run it, you'll see it outputs global twice. So it can be used anywhere in the program. So you'll see with a global variable that can be used anywhere in the program you want, but the local variable is limited to the space or scope it's inside. So in this case, local is a variable, or var is a local variable, so that can only be used in the function hello. You can read files directly from your bash script. So I'll save that I want to use bash, then specify a file name. So I create the file called test.txt, and then you say while read line, semicolon do, and you want to echo the line, done, and you want to input the file. So if you make it executable, and then run it, you see now it outputs the contents of the file test.txt. So you can do this. You can read a file with this script that you can download as attached file. Now, if you want, you can also add something in front of your echo. So puts a line, puts a star now in front of the lines. It doesn't really matter. So this is how you can read a file with just 4 lines of code. You can create a file directly from bash. So let's say I'll create a file called myfile.txt, and then we say echo this is my file, and we save that into file, and probably also want to output it, so you can use cat to output it and add a $sign there so that it's a variable. Make your program executable, run it, and you'll see it created a file and appended a line into the file. So this appends a line into the file. If you want, you can add another line into the file. So another line. So now another line is added into the file. But do note, if we run it again, it's added just after the file, but the original contents is still there. So you might want to remove a file before you actually add new contents. So depending on whether you want to append to a file, you can just do it like this. Or if you want to create a brand new file, you can remove the file like this. So that will create a new file each time you run it. So you see, no matter how many times you run it now, each time it creates a file with just 1 line. So because we remove the file beforehand, so if we don't do that, it's appended each time. Now the file is always removed, even if it already exists. So that even if it doesn't exist, so that doesn't make sense, right? If it doesn't exist, why would you remove it? So you can conditionally run this line of code, conditionally remove it only if it exists. So to check if it exists, you can use an if statement. And then these quotes say, if your file exists, and a semicolon, then do the line, remove the file, and finish. Now it only runs that line of code if the file actually exists. So save it, and if we run it, you'll see it looks like it does the same, but the difference is that it only removes the file if it exists. So it only executes the code conditionally. You can also say file exists removing. So now it will only, you'll see that it exists, so it's removed. But if it doesn't exist, then it's not removed. So let me just remove the file manually. And then run it again. And you'll see now it doesn't remove the file because we deleted it right before. So using this if statement, you can check if a file exists. And don't forget to finish. So if you don't finish the if statement, it gets messy. So you always want to use the if statement in combination with the finish. Now you can also save command line outputs to a file that you'd normally see in your bash terminal. So let's say if you have the command ls star.sh, that will list all the bash scripts. So if I run the script, you'll see it shows all the bash scripts in the current directory, and we can store the output into a file. So we define a new file, say output.txt, and then we can store it into the file like this. Now, if we run it, you'll see it looks like it doesn't store anything. But if we look inside the file output.txt, you'll have the command output. Now, this works for any command. So let's say you have date and you store the date command and store it into the file. Then run it. If we look inside the file, you'll see it's saved the date into the file. This really works for any command. So if you were, for example, to list the network, devices with the command ifconfig. That will show the network device info. So a lot of data on your network. That will be stored in the file as well. So any command can be typed here. And let's just remove the file so that we don't have any output from the previous run. And run the program. We now output the file. You'll see the command line, the bash output from the program ifconfig is now stored in the file output.txt. Have any bash program, you can save the program's output. So let's say you save the output of the ls command. So we have the command ls -al, and let's list all the bash scripts. So we store the output in a variable called, let's call it output. Then we can output that. So the variable output is actually stored. This is our bash script. If you run it, it doesn't output anything by default. You'll see it just runs the command in the background. And you can output it very easily. So echo with the quotes, $, and then out like this. Now if you run it, you'll see it outputs all of the shell files. Now you can easily select only a subset of your output using the command grep. So if I say ls -al and then add a pipe there and type grep and then whatever word you're looking for. So let's say we're looking for the word example. It only lists the ones with the word example. You can do the same in bash. So if I say grep example and then run it, you'll see it only lists the files with the word example in it. And this works for any command. So if you have the command, let's say netstat -antop, this lists all your network connections. So we're going to save that. If you then run the program, you'll see it lists all of the connections. And let's say we only want to know which connections Firefox have, the web browser. So add a pipe there and say grep Firefox. And now it will only list the connections that Firefox has. So you can easily get any program's output, even if you want to store something as simple as date. So you can say date like this and echo it, and it saves the output of the command date. This really works for any network, any bash command you run, and you can store the output called stdout or standard output into the variable you want. So let me give you another example. Let's say you want to output a file. So we say cat output select.sh, which will output just the same file contents as we're running. So if we run the program, you'll see it outputs the file contents. And we can store that into a variable. So let's say add parentheses around it, and we call it my file. Echo your file, and you'll see when you run it, the file content is actually stored. And to make it not print everything on one line, type -e, add quotes, and curly brackets. And then when you run it, it outputs the actual file contents. And you can subselect from that using grep. So if I say grep whatever line contains bash, you'll see it only outputs the the lines with the word bash in it, which are these two lines. So that's this line and this line. Or you, for example, you could only output the lines with the word cat in it. And then when you run it, you'll see only one line has the word cat in it, which is this line. So you can use grep to subselect from the program output, but the basic way to store variables is like this. So you define the variable, then the brackets and your command in there, whichever bash command you want, close it, and then this is how you output the variable contents.